How's it going, ladies and gentlemen? Mr. Johnny here again. We're taking a look at chapter 14.3, concentration and rate. So I'll start with 8. It says a second order reaction in terms of carbon monoxide concentration will blank if CO2 is doubled with everything else kept the same. So we remember that rate equals the rate constant times, for this it's saying carbon monoxide and it's second order. So it's going to be squared. So it's saying if we were to double the concentration, what would happen to the rate? Well, let's just plug in some numbers. Let's say it was K and the concentration was 1 squared versus if we were to double its concentration, 2 squared. Well, the rates would equal 1 and 4. So what happens to it? It quadruples. And that is how I'm going to guess you spell quadruple. All right, 9 says a reaction is determined to be third order in X. Tripling concentration of X will increase reaction rate by a factor of blank. So again, this is just like the last one, but different. So we have the concentration of X, and it is cubed, third order. So it's saying, well, what if we had 1 cubed versus 3 cubed? Well, what's going to happen to the reaction rate? Well, this 1 cubed is still 1, but 3 cubed is 3 times 3 times 3, which is 27. So how much are we going to increase the reaction rate by? By a factor of 27 times. 10. If the rate law for the reaction 2x plus 3y gives you products as second order in terms of x and first order in terms of y, then the rate law is what? Well, rate equals the rate constant times second order in x, so concentration of x squared, first order in y, so concentration of y to the 1, which you don't have to write, you could just leave it like that. That's it. 11. The rate law of a reaction is rate equals K times concentration A times concentration B. The units for the rate constant are blank. Alright, so let's think about this. The rate is usually given in molar per second, and that has to equal K times, let's just look at the units. Well, concentration is going to be molar times molar. So we have moles per second has to equal K times molar squared. Alright, well, let's get K by itself. So we got to divide each side by molar squared. And you get K equals blank over seconds times molar, or molar to the negative 1 times seconds to the negative 1. So that would be the units right there. 12. Use the reaction below in the following data table to determine the rate law for this reaction. So we have to figure out, well, what's the rate order in terms of x and what's the rate order in terms of y. So in order to do that, we have to isolate. So if we take a look at experiment 1 and 2 over here, you can see that the x's are the same and we change the y. The y goes from 0.212 to 0.424. So what we're doing here is we got pretty much 1y, and then here we got 2y, and we take a look at the initial rates. Well, if the initial rates don't change, when we change the concentration of y, that tells us that the reaction order for y is 0. Concentration of y isn't going to have an effect on the reaction rate. So now we got to do the same thing for x. We got to find 2 experiments where y is the same. All right? Oh no, no eraser. So that would be experiments 1 and 3. Right? If we take a look at 1 and 3, y stays the same, but x changes. So here we quadruple x. It goes from 0.363 to 1.452. So we go from 1 to 4. And what happens to the reaction rate? Well, it goes from 2.6 to 41.6. So that is a 16 times difference. So we go from 1 to 16 times. All right, well, that's like saying x to some number equals 1, and then 4x to some number equals 16. Well, what's this exponent got to be? It's going to have to be a 2. So we know that it's second order for x, 0 order for y. So you can write it a couple of ways. You can write r equals k x squared and leave it as that. that's fine, because the zero order of y you can omit. All right, what's the rate law constant? It actually wants you to solve for the k. So how are you going to do that? Well, you already know the rate law expression. You know different experiments, so let's just pick one. Let's take a look at one. We know that the concentration of x is 0.363, so let me just plug it in. Rate equals 0.363 squared times k, which has to equal 2.6 molar per second. So now we just got to get k by itself. Divide each side by 0.363 squared. And what do you get? You get k equals 19.7 molar to -1, seconds to -1. 13. Based on the following reaction and data, what is the overall reaction order? So again, we're going to have to take a look at the reactants and figure out the rate order for each one. So if we want to find out the rate order for ClO2, we got to find two experiments where OH is kept constant. So if we take a look, experiments 1 and 2 are perfect for that. OH doesn't change. We go from 1 to 4, right? Between 2 and 1, and what happens to the reaction rate? Holy crap, that's some big numbers. What do I got to do? You just, divide. You do a little division. 0.34 divided by 0.0002125, and you get a number. You get 16, right? So you go from 1R to 16R for the reaction rate. So what's that tell you about its reaction order? Well, 4 to 16, well, that's 4 squared. So we know that ClO2 is going to be second order. Right, so let me just start writing the rate law. ClO2 is going to be second order. All right, well, what about OH? We got to do the same thing for OH. Find two where ClO2 are kept the same and the OH is different. All right, so here 0.01, 0.01 for ClO2. Take a look at OH. It goes from 0.04 to 0.12. So that goes from like 1x to 3x, right? We tripled it. Right, and we take a look at the reaction rate. It went from 1R, and then you go, all right, well, what's the difference between these two? How different are they? 0.0006375 divided by 0.0002125, and you get 3. All right, well, if I tripled concentration and I tripled the reaction rate, that must be first order. So it's first order in terms of OH minus. All right, well, what is the rate constant? Again, is asking for K. So you just pick one of these trials, one of these experiments, and plug in your data. I'm just going to go with the first one. So I know my rate law is R equals K, ClO2 squared, OH minus to the 1, and I want to solve for K. So I do a little algebra, I rearrange some things, and I get K equals R divided by ClO2 squared times OH minus. So now I just plug in these numbers, 0.04 for both of them and 0.0034 for the R, and I get K equals 53.125, and the units on that are going to be molar to -2 times seconds to the -1. All right, well, hope you found that helpful. Bring some questions to class. See you there.